Okay, so special quadrilaterals. We're just going to talk about all the quadrilaterals that we've already learned about. So we have lots of them. Okay, and you'll see a couple different diagrams that relate these. So the first one is what I like to call a family tree diagram. Okay, so this is when we start out and we say, okay, all of them are quadrilaterals. Girls, you're late every day. So first we have quadrilaterals, and quadrilaterals break into parallelograms, right, or kites or trapezoids. Those are the three different types of quadrilaterals that we talk about. We also have generic quadrilaterals that are nothing, like that aren't any of those, right? And parallelograms from there break into what? A rhombus and a rectangle, yeah. And then a rhombus and a rectangle, its baby in the family tree is a square. You got it. So that is the family tree diagram. Do you think you would be able to fill that out if I had that on a test? Okay, what if I had the Venn diagram one? Okay, it looks a little overwhelming, but we got this. So we're going to start with the big square is quadrilaterals. Okay, and then inside of quadrilaterals, we have three different types. We have kites, trapezoids, and parallelograms. Where do you think the parallelograms go? Left, bottom, or top right? Bottom, exactly. This is going to break into parallelograms. And then parallelograms break into rhombus and rectangle. And together, rhombuses and rectangles make a square. Right, so we have all that portion filled out. Now we got our choices between kites and trapezoids, and one of them has an inner circle. We did talk about a specific type of trapezoid. Do you guys remember what we called them? Isosceles trapezoid. So we have a trapezoid, and then inside we have an isosceles trapezoid. And then over here, all by itself, is a kite. Oops, there's a T there. Okay, could you fill in that on a test?
Yes.
Okay, you will have one of those. I don't know which one. Just depends on the day. So we'll see which one I'm feeling on that day. All right, so let's see if we can remember all of these different properties. So a parallelogram that has 5 properties. The first one is its definition, which says that opposite sides are
congruent.
Parallel. They are congruent as well, but its definition says, because it's parallelogram, right? Opposite sides are parallel. So opposite sides, parallel. We're going to use symbols. Geometry, we love symbols. Okay, how about the next one? So you said, Cam, opposite sides
Are congruent.
are congruent. Exactly. How about angles? Opposite angles?
Are congruent.
Mm-hmm.
Or parallel.
Opposite angles are congruent. Consecutive angles. Do you guys understand all of my abbreviations? Okay, 5th one is one everybody always forgets. Diagonals bisect each other. Exactly. Diagonals bisect each other. I could probably just say diagonals bisect, and you know what that means, right? All right, rhombus. Colin, you getting organized back there? Oh, thank you. Do you know where your notes are? All right, what's special about a rhombus? So it has all the properties of a parallelogram. Yeah, what do you think, Rhett? So we're going to say all properties of the parallelogram. All 4 sides congruent. Okay, this is when I would always draw a rhombus. And a rhombus, as you know, as you guys know, is kind of like the diamond shape. So what do we think with the rhombus? Anything with diagonals? Diagonals are perpendicular. Anything with angles, like cut by the diagonals? Do you guys see? Like, how about these angles? These angles? So we say diagonals bisect opposite angles. Did someone say that over there? Love it. I know, Cassie's got these down. All right, and basically you can get these from all the, that's very tiny. I don't know if you guys can see my marks, but you know what I'm saying there? All right, so basically if you just draw a really exaggerated one, you can get all of them. So that's what I always did, like when I had a rectangle, and I was like, what's happening with a rectangle? Are those opposite angles bisected? I would draw a really long rectangle because then I'd see that this angle looks much bigger than this angle. You're going to see it doesn't bisect these opposite angles. These are not the same angles. So we would need like 2 marks and 1 mark. So I don't include that on this one, okay? So I would say all properties of a parallelogram we don't have all 4 sides congruent, but we have all 4 angles congruent. They're all 90 degrees, right? Anything else? Are the diagonals perpendicular? Nah. The diagonals don't bisect the opposite angles. Nothing like that. Anything else? I don't think so. I think that's it, right? How about a square? So it's going to be all properties of a parallelogram, a rhombus, and a rectangle. Okay, so it's basically all of the things. So when I say a square, you should know that it has all 4 sides are congruent, all 4 angles are congruent, diagonals are perpendicular, diagonals bisect opposite angles, and so on. Right? Next up, kite and trapezoid. So again, if you need to, you draw a really exaggerated kite. And you think to yourself, are these angles the same? And they're not. This other angle opens wider than the first one, right? Does that make sense? But we have some things here. So this is a kite by definition has 2 pairs of consecutive sides are congruent. So 2 pairs of consecutive congruent sides. Okay, that's its definition. Okay, and its diagonals are perpendicular, like a rhombus. The diagonals do bisect, like the diagonal is bisected for one of the diagonals. So one diagonal is bisected. Do you know what I mean by that? So like this piece here and this piece here are the same. Those 2 pieces are the same. Maybe I shouldn't do the same marking. Oh man, I'm running out of markings. Got to do 3 now? Oh, that's rough. All right, anything else you think with this one? One more thing with diagonals. The diagonals bisect what? Which ones? Yeah, the top and the bottom, but we don't want to say top and bottom because I could have a kite on its side, right? So I'm going to say diagonals bisect one pair of opposite angles. Okay, trapezoid. Its definition, exactly one pair of parallel sides. So just one, not 2. That would be a parallelogram. I think that's it. Anything else? Oh, we could say something about the angles, I guess. Like this angle and this angle are supplementary because of the parallel lines cut by transversal. Then the base angles would be congruent. That would be for the isosceles trapezoid. Good. Yep, that's going to be the next one. You're already ahead of the game, Charlie. All right, so I would say 2 pairs of supplementary angles. And then the last one, isosceles trapezoid. So that's when we have like 2 sides are congruent and then those base angles are the same. And we don't just call base angles the ones on the bottom. We have the ones on the top as well. Those are the same as well. So legs are congruent. Base angles are congruent. And with that, there's 2 pairs. Okay, and let's think about diagonals. In the last one, in the trapezoid, was this diagonal the same as this diagonal? No. Like, you can definitely tell the downwards diagonal is, like, much longer. What about here, though? Would those have to be the same, you think? Yeah. So imagine, like, with patty paper, right? You can kind of fold it and be like, oh, yeah, those are going to be the same. Yeah, so diagonals are congruent in that. Okay, that's all of our properties. Can you do all of that on the test?
Two pairs.
So there's two pairs of base angles. So there's the bottom one, that's a pair, and then you have the top pair as well. If you can do all of that on the test, you'll be good to go. Because they're like, that's a lot. It's a lot. Flashcards recommended. I would make some flashcards. All right, so here goes. So quadrilateral ABCD has at least one pair of opposite sides congruent. What kinds of quadrilaterals meet this condition? So at least one pair of opposite sides congruent. So let's go through our Venn diagram. Okay, at least one pair of opposite sides congruent. Does a kite have opposite sides congruent? No, it has consecutive sides. They're not across from each other, right? Opposite sides would be like this one and this one. Those are not congruent to each other. All right, so a kite does not. How about a trapezoid? No, but an isosceles trapezoid? Yes. So isosceles trapezoid. Okay, what else do we think? Parallelograms? At least one pair of opposite sides congruent? Yeah, it actually has both. So we're going to say parallelograms, and then every kind of parallelogram. So a rhombus, rectangle, square. You know what I did for your homework, which is so nice. I typed all these out, and I said circle the ones that make this true. So nice. All right, so ABCD has at least two congruent consecutive sides. Well, that sounds like a kite, right? Two congruent consecutive sides, so definitely a kite. Parallelogram, not necessarily, right? So a parallelogram, you could have a really like long side and a really short side. They're not congruent consecutive, right? Those are not the same. What type of parallelogram would, though? A square and a rhombus, exactly. So rhombus and a square. Diagonals are perpendicular. So what quadrilaterals meet this condition? So you kind of go through your list. You're like, kite, are my diagonals perpendicular?
Yeah.
Yeah. A trapezoid? Nah. Isosceles trapezoid? No. Parallelogram? Not necessarily. Rectangle? No. Square, right? How about a rhombus, though? Yeah, rhombus as well. So you're just kind of going through and you're saying, does this work? Yes. Does this work? No? Okay, does this make sense? All right, another coordinate proof one. I know you guys love these. So go ahead and find your points. So we have -1, 3. That's going to be P. We have Q as 4, 2. We have R as 1, -1. And we have S as -4, 0. Okay, what does it look like to us? I think it looks kind of like a parallelogram, maybe even a rhombus. Doesn't it look kind of like a rhombus? It's like, ooh, are those sides the same? So if you're going to show that something's a parallelogram, the easiest way to do it is to just show that the slopes are the same for the opposite sides, right? But if you're trying to decide if something's a parallelogram versus a rhombus, how do I need to go that step further? How do I need to say, oh, this isn't just a parallelogram, Colin, put it away. This isn't just a parallelogram, it's a rhombus. How do I do that? How do I distinguish between the two? He's a reader, I tell you, he's a reader. Yeah, you say that the opposite sides are, or you say all the sides are congruent. If you're going to go with the sides being congruent anyway, if you're trying to determine if it's a rhombus, I would just go the sides route, finding the lengths of the sides, right? I wouldn't waste time finding if the slopes are parallel. You know what I'm saying? I would go the opposite sides are congruent route because I'm trying to figure out what those sides are. So let's find the length of PS. When I want to find the length of PS, I just write it with a PS and no line over it. And we're going to do this for each one. You ready? All right, so PS is going to use these 2 points. So I'm going to have -4 minus a -1, so +1 squared, 0 minus 3 squared. Y'all remember the distance formula? Do I need to write it? Like that? That's what we're doing. So I get negative 3 squared, which is 9, plus negative 3 squared, which is 9. I get the square root of 18. Okay, don't worry about rationalizing. We don't need it. How about QR? QR, same idea. So I do 1 minus 4 squared plus negative 1 minus 2 squared. Don't I still get square root of 18? Yeah, so those opposite sides are definitely congruent. Okay, then I want to find the top, so let's do PQ. Same idea. So I do 4 minus a negative 1, so plus 1 squared, and then I do 2 minus 3 squared. So I get 5 squared, which is 25, plus 1, I get the square root of 26. Did you guys get that as well? I really thought it was going to be a rhombus. It's clearly not, is it? Is that what you got? Did I make a mistake? No? Okay. And then PQ, so then let's find SR. SR, we end up getting negative 4 minus 1 squared. It is the same thing. 0 minus a negative 1, so plus 1 squared. It's the square root of 26. So we didn't get that it was a rhombus. We got that it's just a parallelogram. Okay?
So there's no like specific category for it?
Its specific category, the most specific it got was parallelogram. So it's a quadrilateral and it's a parallelogram, right? So we're going to say opposite sides congruent. So it is a parallelogram. And you can just write it like that. I know you guys love spelling out parallelogram. Just do the simple, it's fine. All right, so maybe a faster way is if I was like, ooh, I really want to test really quickly if it's rhombus, I probably should have done like PS first and then maybe like PQ, right? And then if I saw, oh, they're not the same, what could I go to? I could do slope then. Does that make sense? If you're like, ooh, they're definitely not congruent, I'm going to go to slope. All right, so number 5. So it says decide whether the following statements are always, sometimes, or never true. So diagonals of a trapezoid are congruent. Are the diagonals always, sometimes, or never true? So draw a really exaggerated one. Like if I had something like that, is this diagonal the same as this diagonal?
No.
No. Can they be? Yes, if it's isosceles. So we're going to say sometimes. Opposite sides of a rectangle are congruent. Would they always be congruent? Yeah, because it's a parallelogram, right? So always. A square is a rectangle. Does a square always have 4 right angles? Yes. So always. All angles of a parallelogram are congruent.
Sometimes.
Sometimes, if it was a rectangle or a square, right? So we're going to say sometimes. Opposite angles of an isosceles trapezoid are congruent.
Yep.
I think never, right? Because they would have to be like this angle and this angle. I don't think those would ever be the same. Can you draw one that would be the same? I don't think you could. It would end up being like a rectangle or something if they were the same, right? So we're going to say never. And the diagonals of a parallelogram are perpendicular. Can they be? Sometimes, if it's a rhombus, right? Does it make sense? Okay, last little bit. We're almost there. This is another form of coordinate proof. Coordinate proof just means like the thing we did there with, you know, distance, formula, slope, and so on. Sometimes we just have variables. So if I have the point up here in the right corner that says B comma H, what that means is I went over a distance of B and I went up a distance of H, right? Can you tell what this point is and this point is? So what should W be? W should be what point? Over 0, up what?
0, H.
H, yeah.
You pronounce this one.
I don't know why this is always like hard for students. This to me is like so easy, but like I've been doing this for a long time, so I don't know. Is this easy for you guys? Can you get it? Okay, so this other one, if I have Z, that means I go over the same amount that I did here, right? So it's going to be B comma 0 because I don't go up any, right? It's on the x-axis. All right, so this one is saying 0 comma A. That means this distance is A. And it's a square, so aren't they all going to be A then?
Yes.
So what should the point Z be? So I go to the right, A, up,
0.
0, so it's A comma 0, right? What about W? A comma A. Do you understand this process? All right, try 3. A little bit tricky. So it's saying go over B, up B to get to the corner point. I'm also going to need to go over to the left B and up B to get to W. So W should be negative B, comma, positive B. Easy enough? How about Z? Negative B, negative B. It's in the third quadrant, right? Easy. My teacher always used to say clear as mud. Is this clear as mud? It's like an oxymoron. What's mud's not clear? Is this clear to you? Do you understand it? Yes. All right, number 4 is pretty hard though. So we're saying this distance was C, but this distance didn't quite go out to C. It's a little bit less than C. So if I had gone over here, it would be C. But now it's C minus A. In other words, this distance right here is A. Do you see what I'm saying? Like the distance over here is A. Because if I added A to it, I'd have a total of C. Okay, so let's try this. So what should Z be? What do you think?
A comma 0.
Yes, A comma 0. Good job. Because we're going to go over that same amount because the lines are parallel, right? It's like the slope is the same. All right, how about W? 0 comma B. It goes up to a height of B. That's a hard one. All right, this is a rhombus, so that means that this distance here is the same as the distance down, so this should be 0 comma negative T for Z. And what about W? So this distance and this distance are the same, so this should be negative R comma 0. And then the last one, if it's an isosceles trapezoid, we're just going to use symmetry to think about point W. What should point W be? Negative B comma positive C, exactly. Z is right here. What's Z? 0 comma
B.
C. I know, tricky. Heights, right? Okay, make sense? I think that's it. All right.